Hi, welcome to EC&M Tech Talks. This is a series of how-to videos where we cover everything from basic theory and codes and standards that apply to our installation work and maintenance on to how to actually perform some of these different activities. So anyway, I'm Randy Barnett. I'm your host. This is brought to you once again by EC&M Magazine, Electrical Construction and Maintenance. And if you haven't already, you need to go to ecmweb.com. If you go to ecmweb.com and up on the left-hand side, there's a drop-down menu. You want to go ahead and click on that. And the very first item that you'll see is something called premium content. So go ahead, click on premium content and sign up for that premium content. It's free and you get all kinds of good stuff. Okay, everything from videos and like this to webinars, articles, and all of that. You'll find lots of information that relate to the different topics that we talk about. So anyway, as I mentioned, I'm Randy Barnett. I'm your host. I am a journeyman electrician by trade. Have been around for many years doing that. About 20 years ago, I got involved in the training industry and book writing business and whatnot, and have been doing that as well. So today we're talking about boundaries and barriers and barricades. And all sounds like pretty much the same thing to me, doesn't it? But there is a difference. I think one of the problems that we run into that we often do when we use code books is that we start intermingling definitions. We use slang jargon and things like that. And oh yeah, let me get some red tape and I'll set up a barrier or something like that. And that's really not what you're doing. Okay. So if we're going to read and interpret all of our different codes and standards, we need to understand what the terminology is talking about. So when it comes to barriers and barricades and boundaries, we're talking about several different documents. First of all, there's the NFPA 70E standard, which conveniently defines all three of those for us. So we're going to use that. We're going to talk about that. There's certainly the National Electrical Code. Also, even things like here's the NFPA 79 standard, which is the standard for electrical standard for industrial machinery. So there's some requirements in here for barriers as well. So let's see what we can figure out. Okay. So first of all, let's talk about boundaries, barriers, and barricades, just what they are, without even going to the book and reading out of the book yet. So first of all, I have a barrier. A barrier is something that prevents me from inadvertently touching something I shouldn't. So for instance, in this panel board up above, even if I turn the breaker to the off position, the main breaker, I still have an opportunity on, well, I don't know if you know opportunity, but I could inadvertently touch one of these line terminals coming in. And of course, those line terminals are going to be energized, aren't they? Because the main breaker turns off everything down below, but not the incoming power. So I could inadvertently touch those. So the manufacturers are now required by the code is that says we have to install barriers. So here's some little rubber that actually comes, rubber guards, rubber barriers that come with the equipment when you purchase it. And it just simply snaps into place. And now I have some barriers in place. I can't inadvertently touch those live line terminals coming in. There are some holes drilled in there that I could get in there and take a reading. Now, let's take a look at this disconnect switch as well. We open up the disconnect switch and I can see the blades down below. If the disconnect has been wired properly, of course, the incoming line power would come into the top of the disconnect. And then when I open the blades, I interrupt the power on down to the rest of the circuit. So everything from the blades that I see on down should be de-energized. Of course, I say that no matter what I'm talking about, we're always going to follow our proper lockout and tag out procedures and do our live dead live tests and so on. But anyway, so the live terminals would be up top here. However, I cannot inadvertently touch those. There's a piece of plastic and I can't stick my finger all the way back into that piece of plastic and make contact with those terminals. Inadvertent contact, practical safeguarding of people and property when we talk about the code, huh? So that's what that's all about. So that's pretty nice. Okay, safety by design, isn't it? Always a good idea. Anything we can do to protect people. So that's what barriers do. They prevent inadvertent contact for us. Now, boundaries Boundaries are only right here, okay? I keep boundaries up in my head. I know that the limited approach boundary at 480 volts is going to be 3 feet 6 inches. Now, how do I know that? Because there's a table in the in the NFPA 70E standard, not the NEC. Okay? So if I go to it's table 130.4E, then table A is for AC systems, table B is for DC systems. So table 130.4E in the NFPA 70E standards. And it gives me the limited and restricted approach boundaries. I have not set up any red barrier tape yet. I haven't set up any chains. I haven't had any expanding gates, any of that yet. Those are all barricades, okay? So boundaries are up here in my head. So I look in the table and it says at 480 volts, the limited approach boundary to expose fixed circuit parts at 151 to 750 volts phase to phase is 3 feet 6 inches. So it tells me that if I get within 3 feet 6 inches of these live disconnect terminals, that is considered to be a shock hazard. So shoot, I better keep all unqualified people at least 3 feet 6 inches away, right? Probably be a good idea. Now, I can, as a qualified person, to come in here and do some work, I can enter this boundary area, this limited approach boundary area, and I can come in here to do some work. But if I get any closer than 12 inches, it tells me in the table, 130.4E, okay, it says if I get within 1 foot, that is the restricted approach boundary. And the restricted approach boundary is based on, it says, hey, there's some electrical characteristics at 480 volts phase to phase, and electricity, can jump out through the air and cause an arc. And also there's this inadvertent movement. I could be in here doing some work, right, and accidentally move and touch something I shouldn't, whatever. So if I get within this restricted approach boundary of 1 foot at 480 volts, then everything I take inside of that boundary area has to be insulated. Once again, my rubber insulated gloves on my hands and all voltage rated, my voltage rated tools and all of that, everything's got to be insulated that I take inside that restricted approach boundary. And then I can go in, qualified person can do my work, of course. But once again, there's no physical barrier tape, barricade, right? Physical tape to establish this barrier. That's called a barricade. Now, where are we going to set the barricade at? So where are we going to put this piece of red tape or the chain, whatever it is? And the purpose of the barricade, it's also a physical obstruction, just like a barrier is. However, the purpose of the barricade is it keeps people out. Okay? So that's why I'm not going to rely on a little piece of rubber to keep some unqualified person from reaching in here and touching something they shouldn't, huh? So we're going to establish a barricade. And the barricade then is a physical obstruction. It can be cones, it can be tapes, it can be those expanding gates I mentioned and so forth, whatever it is, plastic chain. And then I need signage on that as well. Something that says danger, high voltage, qualified persons only, or keep out of area, something like that. So some type of signage when I'm doing electrical work. Now, I have one more boundary that has nothing to do with shock protection. That's what we've been talking about. Shock protection only, shock protection. So when it comes to shock, we have the limited and restricted approach boundary, but we also don't want to get burned, do we? We don't want to get any burns on our body. No pain on my body at all. That's one of my objectives, right? So I don't want to get burned. That's going to be called the arc flash boundary. So without getting all into 70E, but they calculate, our engineers as far as calculate the amount of incident energy, the amount of heat energy, thermal energy that would come out in the event of an arc flash. And they measure that not in degrees Fahrenheit, but in, excuse me, in calories per centimeter square, don't they? So we come out here and what we're interested in, of course, the calories per centimeter square start to drop off the further we get away. At what point do they drop off to 1.2 calories? We're going to call that the arc flash boundary. What's significant about 1.2 calories, if my unprotected skin is exposed to 1.2 calories for 1 second, that's the onset of a second-degree burn. So I've got to look at, and where's that information available? it'll generally be right on the label or in some documentation, but typically on the arc flash warning label on the equipment. And so now I know, well, I come out here so far, and that's the onset of a 2nd degree burn. Well, I don't want anybody else to get burned either. And certainly if I go within that arc flash boundary, I want to wear all the appropriate PPE. So the arc flash boundary is going to vary depending, of course, on the calculations that the engineers come up with when they do their arc flash analysis studies. So it could be the 3 feet 6 inches, the same as the limited approach boundary, but probably not. Depending, it's either going to be less or more than 3 feet 6 inches. Very common to have it more than 3 feet 6 inches. So what's really important for us to understand, and where I see people get confused in the field all the time, they get confused between the limited approach and the arc flash boundary and where the barricade goes. So your limited approach boundary is a shock boundary based on the tables in the NFPA 70E. You go ahead and whatever that boundary is, that's in your head now. Then you look at the arc flash boundary on the label, and it's going to give it to you in inches or feet and inches, and that tells you where the incident energy drops to 1.2 calories per centimeter square. So which is greater, the arc flash boundary or the limited approach boundary? I don't know. It depends, obviously, on your equipment, but that's where you want to set your barricade. You don't want people to get shot, or you don't want people to get burned. I always tell people to remember, that's only the minimum distance, okay? That's only the minimum. If my limited approach boundary is 3 feet 6 inches and my arc flash boundary is 7 feet, maybe I decide, you know what? I'm going to set my barricade tape up at 10 or 15 or 20 feet or block the room off, whatever it is I'm doing. I want to keep people safe. So those are my minimum requirements. So that's the difference between the boundaries and the barriers and the barricades and so forth, where it all fits in. So barriers, obstructions to prevent inadvertent contact. Boundaries are up here in our heads. And then we set the barricade at either the limited approach or the arc flash boundary, whichever is greater. Now, we also have some requirements in the National Electrical Code for barriers. Right? So we start to look at, well, for one, we've seen inside this panel board. And if we think about it, what if this was the service coming in? And we know that this is the main breaker then. So we don't have control over any power coming in. That belongs to the utility after that point of service upstream from here. And this is our very first disconnect. So we have to always consider, even though we turn the disconnect off, those 2 terminals behind those barriers are energized. And so we need some protection from inadvertent contact. But we're going to find similar rules for feeders as well. What if these conductors are not the service coming in from up here at the top? What if these are coming from a transformer that we own in the building? Then, of course, this is a separately derived system. So if these are tap conductors coming from a transformer, secondary tap conductors from the transformer coming on into this panel, then yeah, I've got to have those barriers in place as well. Why? Well, because I have to go upstream on the primary side to de-energize the transformer. So once again, similar to a service, we have to have the barriers in place if we're tapping secondary taps off a transformer. Now, the same is true, in 240, which is over current protection, Article 240 NEC, we have Article 240.21, which is our tap rules. And that's where we come off of a larger conductor with a smaller conductor, unprotected. We tap onto these larger conductors and we take smaller conductors, and they don't have any protection until they get to that first disconnect inside of a panel. Well, once again, we would have unprotected conductors coming into our panel. So in that case as well, we're going to have to put the barriers in place. So let's look at some of these requirements in the code and see just what we're talking about. First of all, in Article 100, they defined barriers for us in the National Electrical Code. They do not define barricades and boundaries, okay? Because we don't need that when we're working with the National Electrical Code. We're just talking about barriers now. The boundaries and barricades have to do with safety and so forth. So anyway, personnel safety. So let's take a look maybe, for instance, here is Article 215. It's 215.15. So Article 215 is on feeders. Section 15 is on barriers, 215.15. And it says barriers shall be placed such that no energized, uninsulated, ungrounded bus bar or terminal is exposed to inadvertent contact by persons or maintenance equipment while servicing load terminations and panel boards, switchboards, switchgear, motor control centers, and so on, supplied by feeder taps in accordance with 240.21. Oh, so if I am tapping off of a larger conductor, 240.21, this is the rule that tells me 215.15 says I have to have barriers in this panel. It says, or if I'm tapping off of transformer secondary conductors. In other words, if these are the transformer secondary conductors coming in, that's what I'm trying to say, I guess, then I would require to have those barriers in place. And that's according to 215.15. Now, that's for feeders. If we take a look at services, Part 5 is on our service equipment in Article 230. So 230 is on services. Part 5 is on service equipment, and 230.62 is our requirements for service equipment that's enclosed or guarded. Oh, by the way, guarded is defined as well, but it talks about guarded, then it talks about barriers. Barriers shall be placed, what we're talking about, it says in service equipment, barriers shall be placed in service equipment such that no uninsulated, ungrounded service bus bar or service terminal is exposed to inadvertent contact by persons or maintenance equipment while servicing load terminations with the service disconnect in the open position. So even though I've turned the service disconnect to open, once again, we're energized. There's a requirement then, 230.62. Now, also sometimes we might use motor control centers for service equipment. So there's a requirement back in Article 430 in, what is it, Part 8 on motor control centers? Yeah, Part 8. And the requirement is found in 430.97. 430.97 is talking about bus bars and conductors in motor control centers. And once again, there's a requirement, 430.97 E, it's an echo, 430.97 E for barriers. It says barriers shall be placed in all service entrance motor control centers to isolate the service bus bars and terminals from the remainder of the motor control center. Okay, wow. So we have some good examples then for the requirements for barriers in the National Electrical Code. One other place, you know, I'd like to point out to you, obviously a lot of you have industrial electrical equipment out there. So the NFPA 79 standard covers, or it is the electrical standard for industrial machinery. And let's take a look and see what it has to say about barriers and protecting people from electric shock when they're working on our electrical machinery. So we're open up panels all the time, don't we? We've got to troubleshoot, open up the control panel, check the fuses, see what the inputs and outputs are on the PLC, maybe, whatever it is we're doing in there. Okay? And we got to remember, OSHA says that less than 50 volts is a safe working volts. 50 volts and above is where we need protection, isn't it? Okay? So let's see what NFPA 79 has to say. And this is in Chapter 6 on protection from electrical hazards. And we know shock is certainly a hazard then. And so the requirements are found in Section 6.2, which is basic protection. 6.2.3 talks about protection by the enclosures. And so they even give the example that they have a jointed test finger that they have all the diagrams for, and I can't be able to stick that jointed test finger in the enclosure and make any contacts with live parts. Obviously, that would be unsafe. All part of the initial testing in this industrial control equipment and maintenance later on. But anyway, let's see what it has to say about it actually falls under enclosure interlocking and protecting people from electric shock. So 6.2.3.2, number 3 says, all live parts mounted on the inside of the doors that are operating at or above 50 volts RMS AC or 60 volts DC shall be protected from unintentional direct contact by the inherent design of the component or the application of barriers of obstacles, such as that a 2-inch sphere cannot contact any live parts. Well, anyway, so by design, then it talks about we have to be protected. So once again, back to my disconnect switch, I cannot stick my finger back in there and make contact with anything. Oh yeah, I could reach around top if I wanted to. And I suppose I don't know, I really can't feel anything yet, but I suppose if there were some conductor material sticking up, I might make contact, but that's not inadvertent, is it? No, that's where I'm doing something I shouldn't be doing. I'm not following safe work practices in. So even NFPA 79 covers these, this concept of not being able to touch something and through the use of barriers or just the design of the equipment. You know, I'll go ahead and mention too, a lot of times we'll say, oh, well, it's finger safe. And we don't really find a definition for finger safe in the 70E standard or NFPA 79. We have to go to the IEC standards, which talk about protection by the enclosure and so forth. And they talk about the term touch safe, where we're just what we're describing, terminals are recessed so that we don't inadvertently touch something we shouldn't. So that's barriers, boundaries, and barricades. And we've got to remember to pay particular attention to barriers, boundaries, and barricades. Understand the difference between them. Okay? The barrier prevents inadvertent contact. The boundary is in my head, and I set up the barricade at the furthest distance out of my boundaries so that I protect everybody out there. So keep those concepts in mind whether you're working within the National Electrical Code, 70E, NFPA 79. So the main thing is go out of here, keep yourself safe, work safely, pay attention to those barriers, boundaries, and barricades. Once again, this Tech Talk is brought to you by EC&M Magazine, part of the portfolio of the Endeavor Business Publications. So thanks, have a great day, and be safe.